Hi there, and as you could see, I have SPSS opened on the screen, and I have it open to the data file, which you may or may not be able to open in your version of SPSS, because if you have a limited version, it allows you to only open files, data files, with so many different variables. And as you could see, this has 134 variables, and the data view, which I'll click over here, when I go down, you can see that I have a lot of cases in here. I have 439 cases. So you may or may not be able to open it up depending on the limitations. But if you can't open it, that's fine. Just follow along with me. And I'll show you how I opened it. It is called survey3ed.sav, and I have mine on the desktop. So I would simply go File, Open, Data, and it'll open up, SPSS will open up a dialog box, and as you can see, I already have mine on the desktop right here, and I'll just make this a little bigger, and here is my survey file, and I would just click Open. Since I already have it open, I don't want to open another instance of it. So we're going to remember that there are two types of chi-square tests, all right, and both involve categorical variables. What's a categorical variable? It's nominal. It's yes or no. Okay, it's in two categories. It's not continuous. The first thing we're going to do is a chi-square goodness of fit test. All right, and that takes a look at the proportion of cases that fall into various categories of a single variable and compares them with some other value that we hypothesized. Okay, so let's take a look. I'm just going to jump into the book here, and I'm on page 212, and you'll see a gray area down in the bottom, and it talks about the procedure for chi-square test for goodness of fit. And let's just go ahead and do it. All right. The first thing they want us to do is from the menu at the top of the screen, we're going to go ahead and click Analyze. And since chi-square is a non-parametric statistical test, the second thing that we want to do is go down to non-parametric tests down here, and you'll see chi-square. And I'm just going to move that out. The next thing that you'll see under number 2 is we're going to click on the categorical variable smoke, or smoker, it says in the book, and then move it into the test variable box. So let's go down. If you start up to the top, it's going to be alphabetical, and we'll just scroll down to the S's, and here's my variable that I want. I'm going to move it into the test variable box, and now that it's in there, it says in the expected variables, which is this square here, click on, you're going to find it on all categories equal. In this case they're not. We're going to take values in, and I'm just going to click on that and remove these so I could actually show you how to put them in. So I'm going to put values in, and I want to put two values in. One is for yes and the other is for no. Okay, so let's go ahead and put 0.2 as it says in the book, and I'm going to add that, and I'm going to put 0.8, and I'm going to add that. Okay, and now it is going to take a look under this category, okay, with 1 and 2's, and it is going to tell me, don't forget one, let's go back to the variable view, and I'm going to find it in here, smoke, and smoker, and I'm going to go to the 1 is going to equal yes, and 2 is going to equal no. Okay, and what we're putting in is the expected proportions for the second coded variable. 2 is non-smoker. Okay, so the proportions, where did I get those? I got those from the proportions in the population sample that I took earlier. So I'm comparing the sample numbers to the population numbers that I took earlier for the same variable. and the population variables were 0.2 and 0.8 in the sample. I'm sorry, in the population. So I have those in. I'm just going to cancel that, and I'm going to bring this back in just so you understand it. And the next thing I do is I'm going to hit OK. All right, and here we go. And what it's going to do is I'm just bringing in the box that it just brought up with the analysis that it did. And as you could see, it ran a non-parametric test, chi-square, and the first thing that it did was give me information on smokers. Okay, so let's take a look. There were 85 observed, and I expected 87.2. There were 351 no's, and I expected 348. And that's out of a total of 436. And my chi-square value is 0.069, and my degree of freedom is 1, so it doesn't have much freedom to vary, okay? And my asymptomatic significance is 0.792, and we'll talk about that in a minute. So let's talk about the interpretation of the output from chi-square for goodness of fit, which you'll find on page 213. Okay, in the first table it says the observed frequencies from the current data file are presented, and showing that 85 out of the 436, here's the 85 out of the 436, or 19.5%, were smokers. The expected N from the previously reported proportion specified 20%. Specified is given. All right. In this case, 87 cases were expected, while 85 were actually observed. Okay, and I'm reading right from the book here. The test statistics table, which is down here, reports the results of the chi-square test. Okay, which compares the expected and the observed values. In this case, it says the discrepancy is very small and it is not statistically significant. It's 0.792. Okay, and so what would it need to be statistically significant? Right? 0.05, and that's what I'm looking for here. This is quite a bit higher than that. So in the results, I'm reading again, reporting the results, you need to report the chi-square value, the degree of freedom, and the p-value. Okay, so this is, as you can see in the box down on the bottom, this is how I'd report this. A chi-square goodness of fit indicates there was no significant difference in the proportion of smokers identified in the current sample, 19.5%, as compared with the value of 20% that was obtained in a previous nationwide study. Chi-square, open paren, the degree of freedom was 1, comma, the N was 436, close the parens, and this is what you're seeing here is the APA, or the American Psychological Association format for reporting statistics, equals 0.07. So what we did was we just rounded the chi-square. It's 0.69, so I've used 0.07, and the p is 0.79, and of course that is not going to bring us to a level of significance. So that is how we take a look at a chi-square test, the non-parametric test for goodness of fit. In the next video, we'll take a look, on page 214, which we'll pop over to, we'll take a look at how to do a chi-square test for independence, or between what? Between two variables, okay? Or two categories in each variable. So I'll see you there in a minute.